Hello class, this is Mr. Shu, and I am obviously not in class today, but hopefully you had a wonderful and restful break. You guys obviously already know the reason why I'm not there, but yeah, I've prepared a few videos for you to hopefully get you through the next few days. I know it's not going to be as good as me being in class with you, but in some ways it might actually benefit you because I will not be distracted easily sitting here by any of you, and I can still distract myself, but at the very least, you won't be able to distract me, so maybe we'll be able to get through the material a little bit faster. So yeah, anyways, let's get started. I want to mention a few things. Number one, your cycle sheet is already posted online. It should be on Canvas. Please email me if you can't access Canvas, because they had some changes to it. It's not year-long anymore, it's semester-long, and I'm not the greatest with technology, so I'm pretty sure that, I transitioned all of you guys smoothly into the new second semester course, but if you can't access it for some reason, you can only access first semester, then there's an issue. So please email me and let me know, and I'll respond as soon as I can. So yeah, the other thing I want to mention is that your quiz is coming up shortly. It'll be actually next Friday. So you want to make sure that even the days that I'm not here, that you're reading the book, you're staying on top of your homework, all of that stuff. Okay? Don't wait till the last minute. Another reason why you don't want to wait till the last minute to do your work, especially with this chapter, is because chapter 7 is considered the bridge chapter. Okay? It is still part of the probability unit with chapters 5 and 6, but it is what bridges probability and inference. Okay, like we're going to be using what we've learned in probability to make inferences about population, and we'll see why according to this chapter. So this chapter is really important because if you have a good understanding of this chapter, then for sure 8, 9, 10, and 11 are all going to be easier for you to understand. So I would put in a lot of effort to understanding this chapter. Yeah, like this chapter is like very, very, very important. So that's something I want to mention. The other thing that I want to talk about real quick is today I'm supposed to give you an intro to sampling distributions. Now, normally I have like this really cool lab that we are able to do together that illustrates sampling distributions really well. But since I'm not there, it's kind of tough to do it. So I'm going to try my own lame attempt at doing something that will also illustrate what it is that we're trying to do. So yeah, the German tank problem is actually a really cool problem. Yeah, but anyways, we won't be able to do that. Maybe we'll be able to do it at some other time, and maybe it'll be more meaningful at that time. Okay, so let's get started with our lesson for today. And what we're going to talk about today is obviously sampling distributions, but the three objectives that we're going to focus on are the top three. So distinguishing between a parameter and a statistic, how to define a sampling distribution, and how to distinguish between population distributions, sampling distributions, and the distribution of sample data. Okay, now you guys have already seen distributions of sample data, And I believe we've also talked about the distribution of population data. You've seen it, you might not recognize it, you might not be able to tell the difference between the two, but you've, at the very least, you've seen the population distribution and the distribution of sample data. Actually, any dot plot, stem plot, or histogram, or scatter plot, those are all distributions of sample data. Okay. Bar graph. All right, because all of those are samples. Okay. Now, what we're going to talk about is, okay, how is that different than the population distribution, and how is that different from the sampling distribution? And you really want to be able to distinguish the difference between these three. Okay. So before we do that, I think it's very important to talk about what stats is all about in general. So remember the big picture of stats is that the reason why we need it is that we don't have the population data. So therefore we need to collect the sample. And this sample is hopefully without bias, right? We talked about how to collect an unbiased sample back in chapter 4, right? How to collect a representative sample and all the methods of doing that, simple random sample, stratified random sample, cluster random sample, and there are other ways of sampling, but those are the ways that we've learned in this class. So from there, we then need to analyze our data, and we've talked about how to analyze the data from the sample. We talked about that through chapters 1 through 3, and then after doing that, we need to take into consider chance processes to make an inference about the population. So we are actually right here. Okay, we're on this band. Okay, up here, trying to make an inference about the population. Okay, so inference about the population. Okay. So before we talk about sampling distributions and all of that, I think it is important to talk about the difference between a parameter and a statistic. Okay, now this is actually really, really, really important. Just like in statistics in general, because a parameter is any number that represents some sort of characteristic of the population, right? So that means, in a sense, if you have population data, then if you have data on the population, then any characteristic of that data, such as mu or sigma, are parameters, okay? Because, in other words, those are the mean and standard deviation of the population. Those would be parameters. Now, a statistic is a number that describes the sample, okay? So possibly x bar or mu. So, in other words, if I were to write this down, like if I were to do this, x bar and s of x, these are statistics because they represent sample data, and mu and sigma, these are parameters. Okay. So I just want to mention that there's a big difference between the two. So, like, let me give an example of what would be a parameter and what would be a statistic. If I said the mean ACT score of all LFA students was a 27, Okay, I didn't know what it actually is, but that's just kind of my guess because I think you guys are smart, intelligent people. And so that's my guess as to what it would be. And then, so if that's the case, then if I were to, an example of a sample would be, well, if I took my AP Stats class, now obviously this isn't a representative sample, maybe because you guys are smarter, the mean of my sample, okay, of my AP Stats class, the ACT score is like a 30, right? Now the AP Stats class is a sample of the population of LFA students. It's not a representative sample necessarily, but it is a sample. And that parameter would be X, or sorry, not parameter. That statistic would be X bar. So the 30 would be X bar, and the mu would be the parameter, okay? Or sorry, the mu. My brain's, I'm not getting enough sleep. My brain's not quite functioning properly. The mu would be to the 27, the ACT score of 27. Okay, so 27, which represents the mean ACT score of the entire population of LFA students, and the 30, which is you guys, would be the statistic. Okay? All right, perfect. Oh, okay. Now, it's kind of important to denote that the notation for these is very, very, very different. Okay? The notation for these is really, really, really different. So what I'd like to do now is I'd like to let you take a look at I'd like to let you guys take a look at a sample problem. I believe I've put it under here somewhere. Ah, here we go. Okay. So I'd like you to take a look at this, and hopefully you can spend some time to work on it, maybe the next 5 or 10 minutes, or not 5, 10 minutes, maybe like 2 minutes, determining what is the parameter and what is the statistic. Okay? So, this is the end of video 1, and we will start with video 2 after you've spent a couple of minutes on these problems. Okay? See you in a bit.